I said, well, I think all right, Nancy Champagne, what you got for domain and range?
Domain,
So
I
much so
got
that like I've gone.
-3 to infinity.
Including -3?
Yes.
And then they moved it and they're like, okay, are we?
And range?
Range, I got -5 to infinity and including the -5.
All right, good. Negative, because it moves left 3, down 5, and the parent function, which is square root of x, would be start at 0, 0. So move it left 3, down 5, that'll give you the domain is -3 to infinity, and then -5 to infinity. All right, I want to make sure that, where's it at? The notes. I just real quick run through those from yesterday, make sure everything's good. I have those. I looked at the homework. I made a couple comments to a few individuals, but other than that, it looks good. Any specific questions we can go over after we kind of run through this? All right, all the transformations. We throw it all at you in one section. Okay, and so vertical shifts, which the vertical and horizontal you tend to be the most familiar with. So if you add a constant, it's going to move it. It's going to move it up. If you subtract a constant, it's going to move it down. So depending upon that value. For horizontal, you have to take that constant away from x and then either square it or put it in the square root or in the absolute value. But it's a little bit opposite. If it's x -3, okay, well, it's going to move right. If it's x +2, it's going to be moved left. So this should say left C units for a plus C. And for a minus C, it should say right C units. Okay, for that. X and Y axis reflections. It depends on where the negative goes. If the negative is with the variable, with the X, it's basically changing a +4 to a -4, which is going to take it from the across the Y axis. If the negative is outside, it changes the final value, which moves it from like the top to the bottom and reflects it over the X axis. Thank you. Okay. And so on the next page, the way it's kind of worded, if y equals the opposite of f of x, then that is where it's reflected in the x-axis, okay, top to bottom. And if it's f of -x, when we're changing the x coordinate, that's going to reflect in the y-axis. Okay. Sometimes it's hard to get examples to show the stretching and compressing. I know on some of these you had, it doesn't look like it hits the x-axis, but it actually does. For this one here, if the constant's out in front, if you have a constant out in front of your function, it's going to stretch it or compress it. Now, I'm sure a lot of you just have a is less than 1 there, but technically it should be between 0 and 1. Because once you go into the negatives, you still get a stretch or compress, but then that also will reflect it. So just for this case here, a is greater than 1. It's going to stretch it up. A is less than 1. Between 0 and 1 is going to compress it towards the x-axis. And then for horizontal, which is kind of opposite, if it's a constant bigger than 1, it's going to compress it. If it's a constant less than 1, it's going to expand it, and it's always going to be a factor of 1 over that number. Okay. So if this is like a 4x squared, it would compress it by 1/4. If this is 1/4, 1 divided by a 4th is 4, it would stretch it by a factor of 4, left and right. Questions on those first two? Now for the back, where you need to try to do these. Now when it says label, I'm looking for ordered pairs. I put the parent function on there. You didn't have to, but that just helps me just to organize it. And so that one moved left 4 down 2. So I'm going to take each of these points and I'm going to move them left 4 down 2 so that I can get the new function. Right 3 down 4, take the absolute value, move each point right 3 down 4. New equation should be x + 2 squared + 6. All right, now these are both stretches or compresses. This is a vertical stretch. So I take my original function and basically just move the y coordinate 3 times, make it 3 times as big. And then 1/3, it's a horizontal stretch by 1 divided by 1/3, which is 3. So take your x coordinates. So 1, 1 goes to 3, 1. 2, 2 goes to 6, 2, and then 3, 3 goes to 9, 9, 3. Take 4 of that. Questions on homework or anything here? All right, we're going to stick in section 1.7. I'll give you some guided notes here in a second. But first, all right, just take a look at that. What you think? What's happening in terms of transformation to that function? The question yeah. All right, what's happening here? Nathan Popio, give me one thing that's going on.
Reflecting.
Yeah, we got a reflecting. Across which axis? The x-axis. Okay, so it's the negatives on the outside, it will reflect across the x-axis, okay? Plus 2, Sierra does what?
2 units. Left. Up.
Up. We'll go up. To be left or right, it has to
right,
be
yeah.
inside of it. If it's totally outside, it's going to move it up. So we got 2 things going on. So that's going to be an issue. Here's your original. Okay, if I move it 2 units up, and then I reflect it, that's your final graph. Agree? 2 units up, reflect. What if I reflect it first and then move it? What if I reflect it first and then move it? Do I get the same thing? No. So that's a problem. Because that means what? That means order's important. Okay, I can't just randomly do the 2 transformations. Well, which one's right? Since I have an equation, this is pretty easy to tell. Plug in a number. Plug in 0 for x. So if I plug in 0 for x, what's it give me? Gives me 2. So 0, 2. So which one is right? The top one gives me 0, -2, so it can't be that one. So it means I have to reflect it first and then shift it up. Well, when I have multiple transformations, order is very important. This little order will make your life simpler. Now I got guided notes for this one. Matt, too much to ask for you to write it down.
What? What's the
What's Perry's right? You're on 10.
there's 6, 3, and 1.
6, 3, 1. What's the blue streak?
6 and 3.
Ooh, big answer for that.
They have lots of teams. We'll see how it goes. See sauce?
Because I was still doing it in the same order. I was just holding it as that, reflecting it as a point.
No one else went off.
Yeah, I was kind of like, moving up the, yeah, we get it. Like I have to write it out. Once I write it out, like I can, and it kind of division.
Have you just read it wrong? No, is that when you came to the consensus? It's like, okay, I will never ever send people to the same game. That's Oh, that is a struggle. What is it now? My main problem with the fact that I just care. I don't Yeah, they didn't even laugh. They just laughed. I know. I didn't get up. I got an extra half mile because I did not want to get up. I probably would have laughed more when I had this Yeah, I don't think
Whatever you need to help you remember these high school RVs, somebody came up with that a while ago. Step. You can't afford an RV in high school. So HSC for stretch compress, reflections, vertical shifts. Go in that order. You go in that order, you'll be good. Because like I said, right here, if you shift that one up first, then reflect it, it's not gonna be accurate. Now let's take a look at, all right, this one here, let's kind of go through this together. I am going to graph the parent function on the grid first, just to kind of help me. Now, as you take a look at the function, 5 minus the quantity x plus 2 squared, the parent function is just y equals x squared. Okay, y equals x squared. Now it says label at least 3 points, label being, listing the coordinates of the points, 1, 1, 2, 2. Now don't list the coordinates of the parent function. But let me go ahead and do this, 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. All right, what else going on with this function? Start with H, horizontal. Is there anything horizontal? Is there a horizontal shift? Tessa, going on?
Yeah.
Yeah, how far? In which direction?
Left 2.
Left 2. So we got a horizontal shift. Stretch or compress, Ian Kelsey. Stretch or compress? No. What's that 5 doing? Vertical shift. Okay, vertical shift. And what's this minus sign doing? This is going to give me a what? It's going to be a reflection over which axis? Reflect over. Okay, since it's outside, it's going to reflect over the x-axis. And it's going to move up 5. Now, it might help if you just rearrange that. You don't have to, but sometimes when you throw that 5 in front, you're not used to that. And so some people want to think it's a multiplier. It's just, you're just adding that piece. So you can think about it as negative x plus 2 squared plus 5. All right, now I got a little bit nicer advantage because what I can do here, and let me see here. I can clone this right like that, and I can do 1, 2, 3. I can move it 4 to the left. And then what would be the next thing I can do? I would reflect it.
Why do you move it forward?
Because I was seeing if you were paying attention. And you were, so it's only 2 to the left. That's why. And I'll flip it, which reflects it over the x-axis, and then what do I have to do? Go up 5. And so it looks like that. But you don't have that advantage. Okay, you can't just clone it and shift it and move it. Now, if you're a really good visual learner, that'll make sense. But here's one thing I'm gonna do is typically it's gonna be better to go point by point. I'm gonna take each point and do the same things we just did, and I'll get the same figure. So I'm gonna take 0, 0 and go left 2, and I'm gonna end up erasing these after I do that, but just kind of just so you have a visual. Reflect over the x-axis. Well, if it's on the x-axis, I can't reflect over it, so it stays right there. and then I go up 5. So I go over 2, I reflected, which doesn't do anything, and I go up 5. So that gives me 0 or negative 2, 5 as a point. Okay, so you can label that or you can put it on the side or whatever. And then I'm just going to take each point and do the same thing. I go left 2 from negative 1, 1. I reflect over the x-axis to negative 1. I go up 1, 2, 3, 4, 5. Goes right there. And one nice thing is take your point. What are the coordinates of that point? Negative 3, 4. You should be able to plug in negative 3. If you've done everything right, what answer should you get back? You should get back 4. And I'm going to take 1, 1 and go left 2, reflect, and then I go up 1, 2, 3, 4, 5. I got that point. Negative 2, 4, go left 2. All right, I'm at 4 now, so I reflect down to negative 4. And I go up, and it should be at negative 4, 1. And then the same thing with that last point. Where does it give me? Left 2, I'll be on the x-axis, down to negative 4. Zero, 1. This one's a little bit easier to figure out. All right, slide it left, reflect it, move it. Okay, you can kind of do that in your head. Some others it's not as easy. I copy that one down. Oh, I should have labeled some more points on that other one. All right, my parent function y equals square root of x. And so hopefully by now you're getting pretty familiar with that. 0, 0, 1, 1, 4, 2, 9, 3. And I'm going to at least move those 4 points. Problem probably. Horizontal shift, is there any?
Left 4.
Left 4. Tyson, stretch or compress? Which way, horizontal or vertical?
Horizontal.
Compression. When it's bigger than 1, it's a reverse. So it's going to compress it by a factor of, anybody? 1/2. Okay, because the 2, if it's bigger than 1, it's going to horizontal compression by a factor of 1/2. Horizontal. Compression. By a factor of 1/2. All right, Kylie, how about any reflections?
Across the x-axis.
Across the x-axis, we got the negative on the outside, reflects over the x-axis. And Riley, how about a vertical shift?
Up 3.
Up 3. All right, I'm going to go point by point. That's kind of hard to do, especially with like the compressions and the stretches, to do that with the whole figure. So I'm going to go point by point. We'll start at 0, 0. And it goes left 4. So it goes to negative 4. Horizontal compression by factor of 1/2. It basically means it goes halfway back to the x-axis or the y-axis. So it's a negative 4. It's going to go to negative 2. Basically, you're cutting the x-coordinate in half. Reflect over the x-axis. Well, it's on the x-axis, so you can't reflect. And it goes up 3. So it looks like it's the point negative 2, 3. All right, double check it. Plug in negative 2. Does it work? Does it give you the same thing? Okay. 2 times negative 2 is negative 4, plus 4 is 0. Square root of 0 is 0. So you end up with 0 plus 3. Negative 2, 3 works. All right, so we got 1 point. Now the point 1, 1. Left 4. 1, 2, 3, 4. Puts me at negative 3. What happens when I compress it by a half? Where's it go to? So negative 3 is going to go to 1.5. Negative 1.5. So negative 3, let me use a different color. So we don't get confused. Negative 1.5. Reflect over the x-axis. And now it goes up 1, 2, 3. And that is the point. What is that point? Negative 1.5. Negative 1.5. 2. All right, do the next 2. See what you come up with, and then I'm going to kind of, the next thing we're going to do, I'm going to pass out on this sheet here. So, see what you come up with for those next 2. You don't have to get a graph, the original function, which is square root of. Well, we moved it up. 0.02 from the point. That's what we should go with. Reflected below it. There's your right. This point right here. It doesn't cut it in half. See that moving up.
So let's have 2.
I do it.
It's done on this way.
I did it right.
Oh, no, we're responding.
What did you say?
Like what? Just
December 24th. You got yours in December 24th. Wait, what time do you want? I got mine on.
I'm sorry, I don't have time.
8:10 a.m.
Negative
Wait,
one.
my drip was low, bro.
because we just got Virginia for the last one. So we'll press on the 24th. I still have to count. And we moved to Ohio. We didn't do that. We're still in like 7th.
Avery, what'd you get for your next point? What are the coordinates?
I got 0, 1.
You got 0, 1? All right, let's take a look if she's right. Starting at 4, 2. If you move it left 4, you go right there. All right, now, let me erase that for a second. It's on the it's on the y-axis. Horizontal compression by a factor of 1. You can't compress it closer to the y-axis because it's on the y-axis. So this one doesn't come into play here. Reflect it over the x-axis, which takes it to -2. and then move it how far up? 1, 2, 3. So she said 0, 1, which is correct. That should be the final, or not the final, or the final spot for that one, not our final point. 0, 1. The last one is 9, 3. All right, left 4 puts it at 5, right? Cut that in half. Horizontally compress it by half. Takes it to where? 2.5. Reflect over the x-axis, which takes it down to -3. Move it how far up? 3. According to that point, 2.53. Here's my graph. Okay, has to look like that. Okay, that the opening down part is the reflecting over the x-axis. Okay, that's where that piece would go over. Okay? You can plug in points to test. Sarah, you with me?
Yes.
Elizabeth?
I'm confused. 0, 2.53 should not be 2.53.
That's what I'm confused.
0?
That's a 0.
Okay.
Again, checking to see if you're paying attention. Good work. So yes, that is a 0. All right, now these have equations, which makes life nicer. This next set does not have an equation. I'm just going to give you a finite graph. So on the top left of that paper I just gave you, copy what's on the left there and make sure you put those points. This graph is what we're going to start with for each problem. Now we're not going to do all of them together, so you don't necessarily need to work ahead, or unless you really want to. Oh no. So -4, -2, 1, 2, 3, -1, 5, 4. So we're starting with that that's our f of x graph. That'll be our main graph, and we're going to do transformations on that one. 3, -1. And 5, 4. All right. So you don't have an equation to plug into, so you got to know your transformations a little bit better here. And that first one on the right-hand side, I'm not going to do that one. You see the graph there, but the +1 just does what? It moves it up 1. Okay, you should be okay with that one. Let's take a look at 110 here. -2 times f of x. What's the 2 going to do? It's a vertical stretch by a factor of 2, so it stretches each point up. What does the negative out in front of that do? It's a reflection over which axis? Over the x-axis. It takes it from the top to the bottom, the bottom to the top. All right, so I'm going to graph each point based upon that. So I'm starting at negative. Now, I got an advantage. It's a little bit easier for me to erase, but do what you need to do to get it right. That's my first point, -4, -2. All right, a stretch of 2 takes it away from the x-axis, so it would go from -2 to -4. And now you reflect it over the x-axis, so what's its final resting spot? -4, 4. Okay. Now sometimes I write my points over on the side because it's a little bit easier, but you don't necessarily need to list each ordered pair for this one because you got the grid where I can find it. All right, the next one is 1, 2, 1, 2. This one starts at 2. I stretch it up to 4, reflect it over to back to -4. So that is 1, -4. And I'm actually going to connect those now. 3, -1. Stretch it to what? We stretch it by a factor of 2, so it goes from -1 to -2. And then it goes from -2, I reflect it to +2, so it looks like I got 3, +2. I'm gonna draw in that line. And then I'm gonna go to 5, 4. All right, stretch that up. So 5, 4 goes up to 8, right? But then what happens when I reflect it? It goes down to -8. So 5, 4, it went up to 8 and all the way down to -8. Connect. And erase those. Erase it. What are the coordinates to that point? That is 5, -8. All right, look what also happens here. The -2 only affects which coordinate in this case? Only affects the y coordinate because we stretched it vertically and then we reflected it over the x-axis. So really, I don't know if it's a shortcut, but if you recognize this, all you have to do is take -2 times each y coordinate for that one. Because that's the only thing that's being affected. So -2 times this y coordinate gives me +4. -2 times 2 gives me -4. -2 times -1 gives me +2, and -2 times 4 gives me -8. Okay, that does work. That does work. Okay, but you got to be careful. That's just only if you only have a vertical stretch and then a reflection. All right, what's happening here? F of 1/2 x. The 1/2 is with the x, so it's not a vertical, it's horizontal. Is it a stretch or compression? Stretch. Now, technically by a factor of what? 2. Horizontal stretch. So really, what can we get away with? I can move each one, but really, I can multiply the x coordinates by what? 2. You can get away with that. Because where's my first point at? My first point's at -4, -2. Horizontal stretch, so I take it from -4 and I double it to -8. I'm not going to change the y value. So that gives me what? -8, -2. So just take each x coordinate and multiply it by 2. So 1, 2 will go to 2, 2. 3, -1 will go to 6, -1. And 5, 4 will go to 10, 4. And then what did I say? 2, 2. I got 6, -1. And then I got 10, 4. Okay. All right, does that make sense there? At least for those two? All right, let's skip that next one. Let's skip 12 and 13. Actually, let's hop down to 115. Hop down to 115. Which is, all right, over here. -2, f of x plus 1, plus 3. All right, we got a ton going on. The plus 1 moves it left 1. Do we have a stretch or compress? Yep, stretch by a factor of what? 2, which doubles it. The negative then reflects it. So you can look at it as a -2. And then the plus 3 does what? Goes up 3. So let's just start with a single point. Start with -4, -2. What's happening to -4, -2? The plus 1 moves it. I want to wait. I want to make sure everybody's with me here. I don't want to get too far ahead. -4, -2. We're going to start with. So think how that's going to be affected. Okay. All right. The plus 1 moves it left 1. Okay, that should be red. Okay. This will change the y coordinate by -2, but I'm going to go through each piece. I'm going to stretch it from -2 to now -4, and then it reflects over the x-axis to 4, and then what's the plus 3 do? Up 3. So now it ends up at -5, +7. Okay, so that's that first point. The next point is what, 1, 2? Okay, let's see what's happening there. It moves left 1. Left 1. Vertical stretch, double the horizontal stretch to 4. Reflect it to -4 and then move it up 3. I got 0, -1. Do we agree? All right, you try the next two. You try, and I'm going to connect those two. I'm going to connect those two. Dominic, what do you think for the next point?
I got 2, 5.
You got 2, 5. That is what I got. So you got 2, 5. Okay, I agree. All right. And anybody on the last point?
I got 4, -5.
4, -5. 4, -5. All right, there's a lot going on in there. Okay, there's a lot going on. One thing here, f of 2 minus x, you got to be careful because you can also think about that as -x plus 2. Okay, -x plus 2. So really the plus 2 is going to shift it left, and the negative is going to be a reflection over which axis? Y-axis. Okay. All right, now I wanted to do one of these, but we're running a little bit out of time. Here's the answers. Okay, it's on the next sheet. You want to try one of those at the bottom at least, but there is, where is it at? There you go, 277.
Wait, never mind.
Oh, electronics integration.
Yeah, we're not doing it.
What you guys do?
We're talking about, what is it called? We're recording?